This video is on theoretical probability. For every event we have, we can assign a number to indicate the chance that event will happen. This is what probability is. All events can be assigned a probability between 0 and 1. A 0 probability is assigned to an impossible event, and a probability of 1 is assigned to a certain event. If the possible outcomes of an experiment are equally likely, then the theoretical probability of an event E is given by the probability of E equals the number of outcomes in E divided by the total number of outcomes. Now, the complement of E, which we've said before is the event that E does not occur, can be found by doing 1 minus the probability of the event happening, because that will be the probability of the event not happening. First example, suppose 3 coins are tossed simultaneously. Find the probability of getting 3 heads and at least 1 head. So we're going to start first by writing down all the possible outcomes. So we got 3 coins, so we could have a head, 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 tail, head, tail, head, head, tail, tail. Then we could have tail, head, head, tail, tail, head, tail, head, tail, and tail, tail, tail. So they're all the possible outcomes. Now for part A, the probability of having 3 heads is just this first one here. This first one here is the only option we have for 3 heads. Now we have 8 outcomes in total. 1, 2, 3, 4, 5, 6, 7, 8. So now the probability of getting 3 heads is equal to 1 out of 8. And then for part B, at least 1 head. So we want all the ones we've got at least 1 head. So we've got 1, 2, 3, 4, 5, 6, 7. 7 of them have at least 1 head in it. So therefore the probability of at least 1 head is equal to 7 out of 8. Example 2. A die has the numbers 0, 0, 1, 1, 4 and 5. It is rolled twice. Illustrate the possible outcomes using a 2D grid. Find the probability of getting a total of 5 and then 2 numbers which are the same. So the first thing we're going to do is put this on a 2D grid. I've already drawn up my grid here. And we're going to put all the possible outcomes using dots, which ultimately is going to be every point on this 2D grid, because with the first roll and the second roll, the dice is the same. So that's on a 2D grid. Then part B, find the probability of getting a total of 5. So the options for getting a total of 5 would be 0, 5, a 0 and a 5, 1 and 4, 1 and 4, 4 and 1s, and then 5 and 0s. So there are all the options of getting a total of 5. So the probability of a total of 5 would be, how many we got there? 1, 2, 3, 4, 5, 6, 7, 8. 8 out of how many? It's a 6 by 6 grid, which means it's 8 out of 36, which can simplify down to 2 over 9. And then part 2, 2 numbers which are the same. We've got 0, 0s, the 1, 1s, the 4, 4, and the 5, 5. So once again, just add these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 out of 36, which simplifies down to 5 out of 18. Then example 3. In a library group of 50 readers, 31 like science fiction, 20 like detective stories, and 12 dislike both. Draw a Venn diagram to represent this information. So with a Venn diagram, we always start with our rectangle. Have 2 circles each inside. One for science fiction. For detective, I'm going to call them S and D. Now have 31 like science fiction, 20 like detective stories, and 12 dislike both. So we're going to have 12 on the outside because that's what dislikes both. Now, this information here, we don't have all the numbers we need for the middle parts. But what we can do is, to start off with this information we've been given here, we can label the intersection there as X because that's common between both. And the science fiction will be 31 minus X, and detective would be 20 minus X. So that is that information we've been given there onto the Venn diagram. Now from here, we can then actually work out the values. We know there are 50 readers in total, so we know all this added together has to equal 50, all parts of that Venn diagram. Then if we simplify that, we get 50 equals 63 minus x. And then from there, we can work out that x would equal 13. And from there, then what I'll do is I'll quickly draw another Venn diagram. And that would be our final Venn diagram. So 13 would be x, which is in the middle. Science fiction would be the 31 minus 13, and detective storage would be 20 minus 13, which leaves us with 7. Now part B, I'm just going to put this over this side here. We first want to find out the probability that it likes science fiction and detective stories. So science fiction and detective is the middle value. It's the intersection between the two. So the probability of science fiction and detective would be 13 out of our total amount, which is 50. And then part 2 is asking us likes exactly one of science fiction and detective stories. So that's exactly one, which would be the 18 and the 7. So probability likes exactly one would equal 18 plus 7 out of the 50, which equals 25 out of 50, which would simplify down to a half. And that is theoretical probability.